What is energy? This section covers the concept of energy itself, what it actually is. In the next sections, we'll discuss its various forms, its properties, how it is transferred, how we obtain it, and how we use it. Most of us have an intuitive concept of energy that goes something like this. Energy is the stuff we need to accomplish physical actions, such as walking, lifting a glass, heating some water, or powering a television set. Although this definition is correct, it's a bit indirect because it really only conveys to us what energy is used for, not what energy is, or even how it behaves. For example, what happens to it after you use it. A curious person might still ask questions like, is energy a thing? Or is it a property? Or a condition of a thing? How do we really define it? How was it discovered? What are its properties? These are some of the questions we will try to answer in this and following sections as completely, briefly, and simply as possible. With perhaps the exception of energy in the form of light, energy is not a thing per se. Rather, energy refers to a condition or state of a thing. I did not expect this. As we will discuss in more depth later, a book sitting on a table, for example, possesses energy, potential energy, because of its condition of being able to fall if nudged off the table. A ball flying through the air has energy, kinetic energy, because of its relative velocity with respect to the ground, and it also possesses potential energy because of its height above the ground. But people speak of energy as if it is a thing. Moreover, we all know that energy can be stored, bought and sold and transported. The reason that energy has all these aspects is, unlike many conditions that object may be subject to, energy is conserved. The condition of having energy is always passed from one object to another, never created anew or destroyed. In this way, energy is pretty unique among conditions. A good example of how energy is passed along from object to object is a water wave. A water wave gives the impression that there is an object moving across the water because the shape of the water doesn't change very much. But there really is not an object moving. Rather, the movement itself of the water molecules is passed from each collection of water molecules to the next through the forces between the water molecules. I can understand that. That's pretty cool to think about, because when it hits the ground, it doesn't stop, right? The water molecules actually merge further into the soil, so that energy is still moving forward, even though it appears to the naked eye that it doesn't. Okay. A good example of how energy is passed along from object to object, I've already read that, I'm sorry. Okay, similarly, people are familiar with heat flowing from one object to another. For a long time, because molecules are far too small to see, people thought that heat might be a kind of fluid-like substance, which some called caloric fluid, that flowed from one thing to another. Nowadays we know that heat energy is the microscopic motion of molecules, and that the state of motion, not the molecules themselves, is what flows from hot objects to cold objects. That's fucking awesome. I feel smarter. The scientific concept of energy. To understand the concept of energy a little more deeply, one needs to first understand the concept of work, as defined by the branch of science called physics. Suppose you push something, say your couch, across your living room floor. Then the measure of the work you do, as defined by the branch of science called physics, is equal to the force you pushed with, multiplied by the distance over which you did the pushing. Work equals force times distance. Right. Suppose you just push on the couch without moving it. Are you doing any work On the couch, in this case, nope. Although you may feel like you're doing work, you may get tired, you're not, because you haven't exerted the force through a distance. That is, the distance in this example is simply 0. That force, just have to say that. Notice that because work is defined as the multiplicative product of force and distance, knowing just the amount of work doesn't tell you whether you pushed with a little force over a long distance or a lot of force over a short distance. You can accomplish the same amount of work either way. Now we can give you our first scientific definition of energy. The energy of an object or of a system is how much work the object or system can do on some other object or system. I want to kill myself. This is really not understandable for me. In other words, energy measures the capacity of an object or system to do work on another system or object. Consider a ball flying through the air, for example. If the ball collides with another ball, the ball will exert a force on the second ball for a moment, which does work on the second ball and causes it to move. The newly acquired kinetic energy of the second ball after the collision is equal to the amount of work exerted on it by the first ball. I need actual example with numbers. It's confusing to me. Because how do they measure force? The force. In the example above of pushing a couch, you're able to do work on the couch because your body has a certain amount of chemical energy in your body from the food you eat. Lie. You cannot eat and have that energy. But alright, we'll flow with them. This chemical energy is released to generate force via your muscles, which you then direct to push the couch across the floor. The change in your body's stored chemical energy is exactly equal to the work you do on the couch, plus any heat energy generated in your body while you do the work. There are a number of ways in which a system or object can possess energy, i.e. the capacity to do work. I kind of want to watch it right now. I've never watched Star Wars, right? I'm saying the Force, but I've never watched Star Wars, and I mean, I will probably not like it, but I have to watch it. I kind of feel like I'm speaking to a crowd that I'm not allowed to speak to because I haven't really seen that movie. So I'm gonna stop now.